So, as promised, we're going to learn how to calculate the polar form of these complex numbers. So I have 4 complex numbers here, and I'm going to do the polar form of all of them. Because I think it's important to see a few examples, because the direction in particular can be quite tricky. Okay, so first step here, and it's a very important one, is to draw a picture. You sort of knew it was coming, I think. So we draw a Cartesian plane just for our own benefit. This doesn't exist, right? But we draw it, and it's super useful for doing this kind of thing. All right, so 7 across and 9 up, so a bit more up than across. All right, so a rough drawing there. Okay, this one here, it's -3 across and 5 up. So it ends up looking something like that. -2, -4. So it's -2 across and -4 down. Ends up looking something like that. All right, don't forget they're vectors, so they've got arrows. And finally, 0, 5. 0 across and 5 directly up. It's going to be a bit hard to see, but it's right there. Boom, boom. Okay, so there are my 4 things. Now, this is not me showing you. This is the process, right? I'm showing you this is the process. You should do this. Okay, we also, now that we've drawn our pictures, we need to think about the magnitudes, the lengths of all of these vectors. Now, to help us, we have Pythagoras' theorem. We have right-angled triangles everywhere, right? Right-angled triangles. Right, oh, not here. Okay, we'll get back to that. Okay, so to find these magnitudes, we use Pythagoras' theorem. So we can say that the magnitude of u, right, this says the magnitude of, is equal to, and it's this squared plus this squared. So 7 squared plus 9 squared. Careful, the magnitude of this squared is equal to 7 squared plus 9 squared. And that's the same for all of these, right? And I'm going to write those up in a second. It's faster for us if we do the first step of Pythagoras' theorem here. And instead of saying that squared equals this, we can say the square root of this equals that. So we don't need to do that square root later on. All right, so that means that the magnitude of V is equal to the square root of, very careful how you do this, -3 squared. It's going to be a positive value, right? -3, but it's a length. So -3 squared, that'll give us +9. They're always going to be positives. 5 squared. All right, we've got W here. The magnitude of that is going to be equal to the square root of -2 in brackets squared plus -4 in brackets squared. Okay, and then the magnitude of A. If you really wanted to, right, you could slavishly follow this formula. You could say, okay, square root of 0 squared plus 5 squared. You could do all of that, but also you should just look at it, right? Because it's 5 straight up and it's nothing across. So there's no diagonals at play. The magnitude of this, you shouldn't slavishly follow formulas when they're not required, right? So you should just be like, well, I know that the magnitude is 5. Done. All right. So we actually done one question without doing any calculations. If it's straight up, also if it was like straight across, don't use your formulas. Okay. Do the calculation. That's all, right? Now, this one here is going to be 49 plus 81, which I think is 130. Square root 130. You'll be tempted here to type that into your calculator and get a decimal answer, but you know all about surds now, right? So you shouldn't do that. You should just leave it as the square root of 130. Now, I did pause to double check in my head that that can't be simplified. It can't be simplified, so we'll move on. This one here is the square root of 9 plus 25, which is the square root of 34. Can that be simplified? No. Okay, there's my magnitude, root 34. Okay, here, root -2 squared plus -4 squared. So that's -2 times -2 is 4. -4 times -4 is 16. 4 plus 16 is root 20. Can that be simplified? Yes, it can. 2 root 5. Okay, that is the first part of calculating polar form, right? We've got all of our magnitudes calculated. What we really need is the directions. And I think I'm going to pause. See you in part 2.